So in the previous video, we were focusing on three special angles in quadrant 1, 30, 45, and 60. And we spend some time on how to calculate the exact values, the points, this red dot here, the x and the y. So now we're going to open it up to quadrant 2, 3, and 4. So basically, we're going to be looking at 30, 45, 60, somehow related to the terminal arm being more than 90 degrees in quadrant 2 here, quadrant 3, and then quadrant 4. And if you notice in all of these quadrants, you still maintain that triangle connected to the circle. Now the only difference is the location and the positive and negative signs of the x and the y. So the coordinates are changing and also the signs are changing. So the goal for today is to figure out the x and y points in the other quadrants related to the 30, 45, and 60 and determine their trig ratios. So I took the terminal arm in quadrant 1, this orange one that I'm moving, and I took it and I reflected across all the axes. So as you can see, the orange one here has actually flipped over the y-axis and moved over to the quadrant 2, over here where the red dot is right now, I'm highlighting. I also took this red dot here and reflected over the x-axis onto here, where there's red dot right now. Oops. And then I took this dot here and I reflected over the y-axis, so from the left to the right-hand side here. So these are all reflections of quadrant 1. And if you notice, there are triangles, and all these triangles in all these 4 quadrants are identical. They are congruent. So what that means is, if you notice the red points here, look at the coordinates, if you can see, they're all the same because they are reflections of each other. They are identical triangles. So that means the base and the height of these triangles are all the same. The question right now is, yes, the triangles are the same, but they're different, located in different quadrants. How is this angle, this green angle, related to the angles, the principal angles for all these 3 terminal arms? So before we talk about quadrant 2, 3, 4, let's focus on quadrant 1 right now and go over the terminology. In quadrant 1, we have a principal angle of 30 degrees. So 30 degrees is one of the special angles we talked about before. And this principal angle will dictate the position of the terminal arm, which is this one here, with the initial arm. Initial arm is always the positive x side. It's always at 0 degrees, we call this. And this whole thing that we are drawing here is called the standard form, or the standard position of the terminal arm based on what principal angle is provided. So let's turn our attention to quadrant 2. So this thing here I'm drawing in blue is the terminal arm. And this terminal arm has a specific type of principal angle, and we'll talk about principal angle in a second. But if you notice these triangles, they are identical from the orange triangle to the blue triangle here. We know that the numbers up here are pretty much, they're identical in terms of the magnitude, the length and the width of the triangles, even though the signs are a little bit different, are different. The angles in the triangle are also the same. So this angle here, right over here, is also 30 degrees. It is a reflection. So 30 degrees is related to this triangle. And that's why there's new terminology here called related acute angle. Related acute angle is the angle that is between the terminal arm and the x-axis in that quadrant. So what is the principal angle in quadrant 2 of this blue line here? Now, principal angle is the angle between the initial arm, which is always this here, the one that I'm drawing in blue, and the terminal arm. So imagine going counterclockwise from here to here. I'm going to big blue curve here. That is called the principal angle. Principal angle dictates from the initial arm, which is always this, to wherever that number goes to. In this case, what is this number here? How can you figure out this number here, this angle here? Well, we're going to use supplementary angle because this whole thing here is 180. It's like a straight line. But we know that this little piece here, this related acute angle, is 30 degrees. So you subtract using supplementary angle, and it will give you 150. So let's do the third quadrant right now. So here's your your terminal arm. Can you guys figure out the principal angle? Now keep in mind, all these triangles are identical, so the related acute angle is going to be 30 degrees. Remember, related acute angle is the angle between the terminal arm and the x-axis in that quadrant. So you go from 0 degrees, which is over here, the terminal arm, I'll use red, and you go all the way around. And we want to figure out this principal angle. And if you figure it out, the principal angle is going to be, you go full 180, and you add on this related acute angle, you would get 180 plus 30, which is 210 degrees. And in quadrant 4, in green, this is also terminal angle. So it's our terminal arm, but what is the principal angle? Well, remember, principal angle means going from 0 degrees, or terminal initial arm, all the way around counterclockwise to this terminal arm. And in this case, what are you going to do? Well, there's a couple of ways, but I'll just show you one way. Well, if I keep on going, I get a full 360, a full circle 360, but I know that this triangle, this little related acute angle is 30 degrees, so I'm going to subtract, and that's going to give me 330 degrees, 330 degrees. So the principal angle here is 330 degrees. So we just completed 30 degrees, and we know that 30 degrees is related to 150, 210, and 330. So now, can you guys try to figure out the principal angle for the 45? So imagine you had over here, that's your 45, but if you reflected it, what would the principal angle be? So here's 45, the middle one, and here's 45, the middle one. So now would be a good time to pause the video and try to figure out the principal angles for the red terminal arms. So for the 45, the principal angle in quadrant is 45 degrees, and we know all of these related acute angles are all 45 degrees, 45 degrees. But we don't want the related acute angle, we want the principal angle. So keep in mind, principal angle starts from the initial arm, goes all the way around to the first terminal arm in quadrant 2. So how do you do that? Exact same thing, supplementary. You take a full 180, and you go backwards, and you end up getting 180 minus 145, which is 135 degrees. Now to get to initial arm all the way to this quadrant 3 terminal angle, you got to go 180 plus a little bit more, which is 45. That gives you 225. And you do the same thing. You go a full 360, but you want to go backwards to this terminal arm, and that's going to give you 315 degrees. So now would be a good time to pause and focus on the 60 degrees. So here we have the principal angles for the 60 degrees, 120, 240, and 300 degrees. And you'll notice a pattern in how to figure out from quadrant 1 to quadrant 2. It seems like to get from quadrant 1 to quadrant 2, from here to here, you're always subtracting from 180. 180 minus that related acute angle. And this one here, it seems like you're always taking 180 plus that extra little related piece of related acute angle. And in this quadrant, it seems like we're always going a full 360, full 360, and then going a bit backwards. In other words, 360 minus whatever related acute angle you were dealing with. So now we're going to recap the special angles and the x and the y coordinates on the unit circle. So if you recap, in the previous video, x is related to cos and y is related to sine, just based on the triangles that we worked with before. So when those special angles have special ratios, cos 30, if you remember those 5 numbers, 0, 1 over 2, going from lowest to highest, we get these 5 numbers, and that will help you sort of remember what these numbers are. So cos 30 is going to be the x, and I can tell you that the x is pretty big, but not all the way to the edge. It's going to be root 3 over 2 and 1 over 2. This is going to be the same thing, the middle one. So I'm going to use the middle one. They're both the same. This one is going to be 1/2 and root 3 over 2, because the x is smaller than the y in this position up here. So now we're going to move on to quadrant 2. So what would be the coordinates of, for example, 120? Now 120 is a reflection of this terminal arm here. So I'm not going to draw the arms. I'm just going to I'll draw the arm here. So what is the point here? Well, we know that the answer is going to be the same number as this one over here. It is going to be 1 over 2 and root 3 over 2. However, something's going to be different. What do you think is going to be different? Yes, the sign's going to be different, because in this quadrant 2 up here, we know the x is negative. And same thing for 135. We go back to this one here. We know that the x and the y coordinate are root 2. They're the exact same. But it seems like all the x's in quadrant 2 are negative. Same thing for 150 over here, which is root 3 over 2 and 1 over 2. Remember, these are reflections of each other. And we know that the x is going to be negative here. But how is it related to trig? Well, keep in mind what we just said. In the unit circle, trig is cos, angle, and sine angle. But when I say angle, I'm talking about the principal angle. So what's the principal angle for this arm over here? Well, it's 120. So 120, 120. And this one here, for this one here, this one here, that's related to the 45, is going to be cos 135 and sine 135. This one over here is also going to be cos, the angle here is going to be 150 and sine 150. And the pattern keeps on going. So I'm not going to continue the pattern because it's exactly the same thing. However, the coordinate is going to change. For 210, well, what is the x and y for this one here if I drew this terminal arm here? Well, it's going to be related to which angle? Well, if I take this, extend my arm here, we know it's related to the 30 degrees. So in this case, I know my x and y are going to be related to this one over here, which is root 3 over 2 and 1 over 2. But what are the signs though? Because we're in quadrant 3, everything is negative because you're to the left and you're below the x-axis, negative, negative. It seems like all the answers here are going to be negative, negative, and negative, negative. I'm not going to actually write down all the answers. I'll leave that to you. Now over here to the quadrant 4, it's exactly the same thing. So I'll take this one for example. What's the trig? The trig expression for the points is going to be cos something and sine something because x and y. But what's the angle? The principal angle is going to be 330 degrees and 330 degrees. And what would the x and the y be? Well, 330 degrees, this one here, this terminal arm here, is related to this one over here, 30. So I'm going to use the root 3 over 2 and 1 over 2. But what are the signs of these? Well, we know that in quadrant 4, the x's are in the positive side. So x is positive. I don't need to put the positive, but the y is a negative. Same thing for all these points. You're going to get some number here. And the x's are always positive, but the y's are always negative. So here we have the summary of all the points on the terminal arm for every single quadrant related to the 30, 45, and the 60 degrees. Now let's deal with the other angles that we haven't mentioned about, 0 degrees and 90 degrees. So over here we have a 0 degree. If I were to ask you what is the coordinate of this, well, we know that this is 1 and 0. Over here we have the 90 degree principal angle. In this case we know the coordinate is 0 and 1. And let's keep on going around the circle. From here to here is going to be 180 degrees. And we know that the coordinate of this point here, if I were to draw the terminal arm here, is also going to be -1 and 0, the x-intercept. And over here, this is going to be 270 degrees. And that's also going to be a reflection of the 90 degrees, which is 0 and -1. So these are our x and the y. And just to recap, x and y are related to cos angle and sine angle. And what is the angle in this position here? Well, it is 0 degrees, 0 degrees. In other words, 0 degrees is going to give you 1 and 0. This one over here, 1 and 0 comes from cos. What angle? Principal angle is going to be 90 degrees, 90 degrees. Same thing for here. Remember that cos 180, cos is the x, and that's going to be sine 180, and so on and so forth. I'm not going to finish off the 270 for you guys.